So in week 3, we moved away from the consumer perspective and started thinking about the producer perspective. How do firms operate and what decisions do they make? This is also where we started thinking about like ISO cost and ISO quant curves, because we had to think about like the production analysis, what goes into producing a good or service. And in that, the different inputs for it. So this is where we went into the idea of capital and labor. So let's go ahead. We're going to do a brief go through, and then we'll start talking about the most commonly missed problems and just work through them. All right, so in these, with the theory of the firm, we started talking a little bit about the function, right? We started talking about short run versus long run, fixed versus variable, what that all meant. In the short run, we do have things that are fixed that we can't change right now. In the long run, everything is variable, right? Most of the time, we're going to end up using Cobb-Douglas production functions. That's something raised to the 0.5. Why? Because it's easy and we can take the square root of it, because if anything is raised to the 0.5 power, that just means take the square root. Much easier math. So that's mostly the realm that we're going to be staying in. We start talking about the marginal product. Marginal product is how much extra product is created each time we add in one more unit of labor. We start talking about average product, which is just the total amount that we're producing divided by the number of labor. And then the total product, which is adding up the amount that we're producing. I know that it gets very confusing. We start talking about total product, marginal product, average product, total cost, marginal cost, average cost, and then everything in between that, right? But we're still going to try to figure it all out. We got this. So we spoke a lot about different graphs. I practiced in the original videos how to draw them, kind of walk through what each of them mean. And then we thought about the production process. So we wanted to graph efficient allocations. To do that, we need to have some sort of consideration for the production. So remember that the production tends to also be some sort of curved or sloped line. Then we had the cost of production. So the cost of production, much like the budget constraints, are a flat line. And this represents the money that we can either put towards labor or towards capital, or some sort of combination in between. While the quantity curves, right, the ones that are production curves, these are the different bundles of capital and labor that can get us that amount of output. So we call those isoquant curves, right? The amount of output that can be yielded from different bundles of capital and labor, isoquants, curvy. Okay. So we have lots of different forms. This goes all the way from linear isoquants. Actually, we'll just draw it out, right? That's just, it seems easier. Okay, so isoquants, generally, when we're talking about the Cobb-Douglas production function, looks something like this, where we have capital, we have labor, and then we have some sort of combinations in between. This curvy one in this class, we represent by Cobb-Douglas production functions, though there are other types of production functions that might be like this. Those mostly take the case of Q, the amount that we're producing is K to, well, in our case, it's the 1/2, but it can be alpha and L 1 minus alpha. And that's how we figure out these curvy lines. For linear, that's the idea that we have substitutes. So substitutes, that means for capital and labor, there's some amount of capital that we would be willing to trade off labor for. They're substitutes for one another. So we will just go with whichever one's cheaper. On the other hand, so actually let's put this as Q equals AK plus BL. Then we have our last one, which is our Leontief, right? Oh, you know, that looks terrible. Let's redraw that. Ooh. The only problem with Wacom tablets is the fact that you can't see what you're writing on the tablet. So I'm just always a little lost. Imagine that this one's straight. Okay, so then we have our Leontief. Our Leontief is where Q equals the min of AK or BL. These are the ones that look like this 90-degree angle, right? They can be that you need 2 pieces of bread for each 1 piece of meat that you put inside of it. It could be the idea that you need 2 pieces of plastic for each 3 pieces of hardware that you're putting inside of it to make a remote. It can be some sort of combination of you need so much of A and so much of B to be able to make something, right? So in this case, this is Leontief. In this case, it's linear. In this case, we got Cobb-Douglas. And these are all different types of isoquants, just different ways that we can think about the production. We represent it by Q. Okay, so let's go back. we talked about all of these. We wanted to pause to remember the goal. The goal is that we want to figure out where it equals cost, right? How can we produce the most possible for the least amount of cost? So the cost curves are here. Do we have more room? Ah, there we go. So the cost curves, they're just flat lines. There's some sort of relationship in between capital and labor, right? So we have capital, labor, it's something like this, right? Where the slope is going to be the relationship in between wages and rent, so minus WR. Essentially, for as much as you give up in rent, that's as much as you have to add in wages to be able to stay on the budget constraint. But this is the total amount of workers that you can hire. So let's say we have 10 workers that they make $5 each. Maybe that's $500 that we can spend on 10 workers. Or excuse me, this is capital. I'm going crazy. If we have 10 machines and $500, that means that each machine costs about what? $50? Yeah. So at $50 for each machine, so if we have a W or an R of 50, then we can afford 10. On this case, let's say maybe we have 20 workers, right? So if we have 20 workers, am I going crazy? 500 divided by 20. No, I'm not. I'm just tired. Okay, so that means that it's $25 for each worker. So let's say our wage rate is equal to 25. So if we had $500 in the budget, we could afford either 20 workers or 10 machines, right? That's just what we're looking at right there, is thinking about these sorts of relationships. So we want the one where where this budget constraint equals the isoquant curve, right? So we're thinking about the iso cost curve and the isoquant curve, and we want that piece where they intersect with each other, where they're tangent to each other, because that means where we're making as much as we possibly can while utilizing efficiently all of our budget and resources. So that's kind of the goal, right? We have to think about cost minimization and product maximization. Normally that would involve a lot of calculus. I don't make you do a lot of calculus in this class, but I do make you kind of think through the graph and do some of these analysis. Now, I do ask a lot of things about time frames, right? It's really important to think about what is variable in the short run versus what's variable in the long run. Less things might be variable in the short run, but everything is variable in the long run. All right. And then we went to the fixed cost, variable cost, total cost. Remember, fixed cost, these are the things that you're going to have to pay regardless if you produce anything or not, right? This is like your rent. It's the machines. Variable cost is the idea that like we can kind of control this. So variable cost is the idea of like I can tell a worker to work more or less. I can hire an extra worker. I can fire a worker. There's some sort of thing that I could do on that piece. Total cost is adding that fixed cost and variable cost together. Sunk cost is when you're not going to be able to get that back. Right? You have invested stuff that you will not be able to reclaim. That's the idea of sunk cost. All right. So after that, we had looked at this sort of graph where I was like, see, total fixed cost stays flat. You pay it regardless. Total variable cost increase with output, which means total cost increases with output. We talked about the short run and the long run. We talked, okay, one thing that we need to talk about is the idea of marginal cost. How much does our cost increase when we add one more? Right? That's going to be important. Let's remember that definition in our head when we're going over the homework, because there was one that a couple people got wrong that I want to talk about. So then we got to this sort of graph. Remember that we, if we can match our average variable cost, well, that's good. That's good. That's the point where we might consider like, yeah, we might operate at a loss, but we will still decide to stay open. If we cannot meet our variable cost, we just close down and just pay the average fixed cost because it's losing less money than if we were losing money on both the fixed and the variable cost. But all this can be affected by technology. We have to think about what happens in the long run. In the long run, we can vary both the labor and the capital, right? If we can vary only the labor, we move around one of these curves. These are the curves that we've been dealing with the entire time. If we can vary both the labor and the capital, much like it's in the long run, then we have a bunch of different average total cost curves, one for each level of capital that we might have. And then the curve that's created by all of it, that's our long run average cost curve. All right, so economies of scale just means this is when we're starting to grow, we're starting to produce more, we're starting to scale up. It's great. Diseconomies of scale is eventually you get so large that you start, it's no longer productive, and you're no longer having cost savings for producing the next one of something. All right. We talked about the ideas of scale versus scope. We already talked about that in our homework, and we're going to go over it again in a second. Then we started talking about the role of a manager. I would, if I were you, at least know the definitions of spot exchange, contracting, and vertical integration. So remember, spot exchange is the idea of we have a one-time trade. We can avoid contract costs. We can avoid some of the cost of integration. We can avoid speculation, but there might be a possible holdup problem. Someone might screw you over, or they don't really have the reliability of wanting to work with you long term to give you a good product, right? Maybe there might be something issue there. Contracting, on the other hand, if we have a contract with someone, this means that we can kind of specialize. We can reduce opportunism, right? We don't have people taking advantage of us because we have a long-term contract. We kind of can avoid sketchy and speculative one-time arrangements. But this is at the cost that they are very costly and complex. You gotta hire lawyers. You gotta set them up. There's negotiation. There's transaction costs. Then we have the idea of vertical integration. So vertical integration says, I'm not going to buy this from anybody. I'm just going to produce it in-house. This does reduce opportunism. People aren't going to take advantage of you if you make it yourself and you avoid all this contract costs. But the problem is you lose specialization of the type of goods that you're making, because now you're making multiple types of goods, and you may have some sort of organizational cost setting up this means of production. All right. So after that, let's go through the homeworks. So when it came to the homework, we had a whole bunch of different questions, right? So we started off with our normal Cobb-Douglas production function. I wanted to see if you could plug in numbers. So this one, I think most people got it right, but we're going to look at it anyways, just because I think it's an important one to know. So we have the function Q equals K to the 1/2, L to the 1/2, right? Which just means that we're going to be taking the square root of something. So in the short run, we have 100 machines. Cool. So that means our capital is 100 to the 1/2. Then we're wondering what we're going to do with labor. So how much production will we have if we have 144 workers? So 144 workers to the 1/2. Oops. Well, the square root of 100 is 10. The square root of 144 is 12. 10 times 44. That just means that the amount that we're producing is 120. Boom. That's the first one. All right. So let's say in the long run, you decide to drastically cut production. You close parts of the factory to focus on making different things. So now you have 25 machines and 25 workers. How much do we produce? Okay. Well, that means that our Q, which is K to the 1/2, L to the 1/2. Then we have Q, which is going to be, let's plug in 25 for each of those. 25 to the 1/2. 25 to the 1/2. That's just 5 times 5, right? This is 5. This is 5. So the quantity that we would be producing is just 25 in the second situation. I would know how to like work through the steps of, if I gave you a very similar problem with maybe similar numbers, being able to run them and figure out which one you would produce more. All right, so the next one, answer the following question about production using the cost table below. So we have a couple pieces here that we need to think about, right? So the first is going to be what the fixed cost is. So we see that the fixed cost is going to be $100. So let's see, we'll put it right here. Oops. Fixed cost 100. That's how much we are going to pay regardless, right? We will always be paying 100. So then we have to think about what the wage rate would be. So wage rate is just number of workers at $50. All right, so for A, what is the marginal product of the third worker? Well, that's how much they increase the total product, right? So that's 48 minus 36. It says we have 36 with 2 workers. We have 48 with 3 workers. That means that we have increased by 12. The marginal product of the third worker is 12. All right, for B, what is Randy's average fixed cost if 48 shirts are produced? So let's see, if 48 shirts are produced, then that means, okay, we're right here. We know that we have 3 workers. So that means that it's $100 of fixed cost plus 50 times 3, because it's $50 that we pay for each of those 3 workers. This together equals 250, which we're going to divide by 48. I don't have a calculator on me, but I think that equals 208. Hold on. There we go. 250 divided by 48. Yeah. 5. No, that's not right. Y'all, I'm tired. I just realized I was thinking about total cost. All right. So if we were doing total cost, let's see. This is why you got to read the whole problem instead of just trying to run through. So if we're doing total cost, the total cost at 48 would be 5.21 for our average. All right, now let's do what the question actually says and look at Randy's fixed cost. So the fixed cost is just that $100 divided by 48. That comes out to a much more reasonable number of $2.08. All right, yeah, 208. All right. What is Randy's average variable cost if 56 shirts are produced? Okay, well, if 56 shirts produced, he has four workers at $50. That means that it's $200. So 200 divided by 50, what, 56? That's going to be equal to $3.57. So $3.57. This part, almost everybody got this part right? In A, B, and C. Where things started to fall apart was D, the marginal cost. And that's the reason why I wanted to look on this one. Marginal cost is how much additional cost you have from producing one more of something. So the marginal cost of producing the 52nd sweater, well, that's how much more are we going to incur from producing the 51st sweater. So the 51st sweater, we know that we have 4 workers. For the 52nd sweater, we know that we have 4 workers. Nothing has changed. We haven't had additional variable costs, so the marginal cost of producing one more sweater in that situation is equal to 0. Then average total cost, you just calculate like I have above, because I just went ahead and jumped ahead of that, but we have our average total cost. All right, so diseconomies of scale. That's the idea of the opposite of economies of scale. Eventually, you stop having cost savings as you get larger. Then we have to think about factors of production. That one's fine. Everybody was fine with the idea of that rent can't really be changed in the short run for this situation of Jake the corn farmer. So that would be more of a fixed cost, while for the workers, he could hire more workers or less workers, pay them more, pay them less, all these other sort of things. Those are variable costs. All right, then we got to number 7, which gave us both an ISO-quant and ISO-cost line. Y'all overthought this one. Not all of you. I'm talking about like 3 or 4 of you, but 3 or 4 of you really overthought this one. So what we're looking at here, you don't have to go through all the math that I made you do in the previous videos. Instead, what I just wanted to have is, let's see, we have capital, we have labor. What do I really ask for? I ask, what is the rental and wage rates? I want to know essentially what that slope is, right? What's the maximum amount that we can afford? Well, here we know that our budget is $100. So we got $100. All right. Well, we know in this budget or in the ISO cost curve that we have 10, or if we spend our money only on capital, that we can afford 10 capital. And if we spend our money only on labor, we have 40 labor. So if we spend our money only on capital, we can afford 10 capital. Then that means that the rental rate is going to be this $100 divided by the 10 that we have. This gives us $10. This right here is going to be our rental rate. On the other hand, let's look at the wage rate. So the wage rate, if we only spend money on workers, the maximum amount that we can afford is 40 workers. So that means if we spend this $100 on the 40 workers, this is what, $2.50. This is going to be our wage rate. That's it. That's all I wanted for this ISO cost. Okay. What is a sunk cost? That's just money you can't get back. How do managers fail or do a bad job at their role of procuring inputs of the least costly manner? I took almost any answer for this. Some of y'all had creative answers. Like normally I just want like, they don't get things efficiently. They pay too much. Maybe they just don't have good exchanges. Maybe they had a spot exchange and there was a hold up problem. Some of y'all were just creative and gave me like really cool situations. Yeah, that's all good. Then the difference between spot exchange and contracting. Notice I didn't ask about vertical integration here. I wonder if that one's going to come up later. All right, now let's look at the quiz. So in the quiz, the first one, production requires 2 inputs, capital and labor. Which one's fixed in the short run? Capital. It's very hard to change the amount of machines that you have in the short run. During the next one, the table above shows the total product schedule for Hair Today, a hair styling salon. So actually, let's work through this one because a couple people got this one wrong. So I want us to think through this one together. So let's look at part A. What is the first worker's marginal product? Okay, well, the first worker, well, we had 0. So actually, let's write this out. Let's say number workers and then total product. So for 0 workers, we had 0. For 1 worker, we have 10. For 2 workers, we have 25. For 3 workers, we have 45. For 4 workers, we have 60. For 5 workers, we have 70. All right, let's see how much they increased. So when we add 1 worker, we get plus 10. That's our marginal product, right? We've increased by 10. When we add a second worker, we go from 10 to 25, which means that the second worker has caused our total product to go up by 15. The marginal product of the second worker is 15. All right, for the third worker, we've gone from 25 to 45. That means that the marginal product of the third worker is that 20 unit increase of haircuts. For the fourth worker, we see that we have a 15 unit increase, so a 15 unit marginal product. And then we have a 10 unit for the fifth one. So 10, 15, 20, 15, 10. That's what that one's. Over what range of workers is increasing marginal returns? Okay, well, let's see. Plus 10, plus 15, plus 20, plus 15. Oh, we start to go down there. Okay, over the range of 1 to 3 workers, this is where we have increasing marginal returns. Marginal returns. All right, then from 4 to 5, and or you could say 4 onwards, like some people said just 4 to infinity, like you're technically right. This is where we have decreasing marginal returns. Notice that we are increasing total product, but by a smaller and smaller amount. Okay. The next one was the idea of rental limbo, right? So what affects average fixed cost, average variable cost, average total cost, marginal cost? We're talking about changing the wage rate of drivers. If we're talking about changing the wage rate of drivers, that does not affect the average fixed cost, right? We're talking about things on the average variable cost, the average total cost, the marginal cost. Average fixed cost doesn't change. Some people thought it did, it doesn't. All the rest of them increase. What does the isoquant line represent? These are the different bundles of capital and goods, right? This is back to, do we still have the picture up? Let's see. This is our iso cost line, which tells us how much we can afford of two things. Isoquant lines, whoop, here is like the different bundles of Q, right? So this might be Q, this might be Q2, this might be Q3. And the different combinations of capital and labor that can get you to that level of quantity. All right. And they can be everything from this bendy piece to linear. They could be a flat line to Leontief, that L shape. All right. The difference between the economies of scale and scope. Scale just means you're scaling up. You're producing more. Scope means you're producing different things. What are the beneficial and harmful aspects of vertical integration? Well, that's where the rest of this came to. I'd still know it, and I would also know contracting and spot exchange. Just I would know all 3 of those, but definitely vertical integration. But in this one, it's the idea that you might start deciding to produce things internally, right? Which can have some issues. You'd stop specializing. You might not be very good at it. There might be issues with organizational cost, but you're not getting screwed over by people on the outside who may give you bad contracts. All right, anyways, that takes us through week 3. If you decide to watch the week 4 one, I'll see you there. If not, good luck on your test.